Hello, welcome to the Omega Squad. This is Babu. I am the coach for this team. I've been coaching First Lego League team for the last 7 years. This is my second year of coaching the First Tech Challenge team. This is something I started 7 years before when my wife asked me to program my son's EV3 Mindstorm kit. Here we are. In this video, the First Tech Challenge team, the Omega Squad, will explain their learning experience during this season. And now I will let the team members to explain their robot.
What's up, everybody? My name is Amog. I'm a freshman at North Creek High School. I've been doing the FLL and FTC competitions ever since 3rd grade, and this is my second year doing FTC. So to get started with this, every single year, a team builds a robot and a mechanism to do its missions. That's assigned by FTC. Building a base robot, mechanism, prototype, and programming are a lot to handle as a group all together. So this is what we decided to split up and do a split up and conquer approach. We broke into 3 groups with 2 people in each group. One of the groups focused on programming the robot, another team focused on the base robot, and finally the third team, which I'm on, focused on integrating the attachments and the functionality to the robot.
Hi, my name is Anchara. I'm a sophomore at North Creek High School. During this season, both the programming team and the engineering team used the engineering design process to build our robot. At the beginning of the season, we had a design session and everyone on the team sort of brainstormed different ideas. And then we decided to go with 2 different distinct attachments to do 2 robot missions. So our first attachment is our main attachment, which is the ring intake and the shooting mechanism. And then our second attachment is to move the wobble goal. Both these attachments started sort of as an idea during design discussion, but then we came up with a free sketch drawing, we built a prototype, and we tested and repeated this cycle before integrating this with the base robot. And we're still testing right now to continue to perfect our mechanism.
Hi, I'm Darshan, and I helped build the base robot. The parts of the base robot were borrowed from GoBuilda, and we used 4 DC motors with RPMs of 312 to connect to the wheels. The wheels were special Mecanum wheels, which were also GoBuilda's, and the benefit of those is to strafe or drift. We connected the motors with the wheels using a hex bore miter gear. The dimensions of the robot that we built is 43.2 centimeters by 9.6 centimeters by 45.3 centimeters. At the end, we mounted a expansion hub, a control hub, and a camera on top of the robot to monitor how it was going to move and how it was going to work with the code.
Hello, my name is Gaurav, and I helped build the base robot. The base robot was built so we could be able to test code. We did run into some trouble on the along the way, but luckily me and Darshan were able to figure out what we did wrong and fix the robot.
I helped build the wobble goal prototype attachment. The purpose of the attachment is to move the wobble goal to one of the 2 locations. The first location is the target zones inside of the field, and the other one is outside of the field. The wobble goal prototype attachment works almost like a claw. It grips the wobble goal with a Rev Robotics servo motor, and it will be lifted at a 120-degree angle with a DC GoBuilda motor. Then it will be transported to one of the 2 said locations.
Hi, I'm Sweta, another member of the Wobble Girl attachment team. We faced multiple obstacles while making this prototype, like the claw didn't have a good grip on the wobble goal, and when the programmer didn't work correctly, and also the DC motor didn't have the capacity to lift the wobble goal. We managed to fix and manipulate these problems by changing the parts and sometimes changing the design of the whole prototype. The attachment is now mounted over the right wheel.
For watching part 1, stay tuned for part 2 where we'll explain more features of the robot.